Hello my dear students, how are you all? Welcome to Deeksha YouTube channel. I hope all of you are doing good. So bacha, we are going to start another session today. Okay, we'll complete the chapter in one shot. As you know, we are doing KCET Masterstroke for mathematics. Today's chapter of discussion is going to be vector algebra. Again, we'll complete our the chapter entirely in the session today itself. Okay, and as you know, we'll give more attention to the concept part first. Yes, I have taken some questions. I think I've taken total of 8 questions today to help you bridge the the gap between the concepts and the problems. Okay, so let's start without wasting any time. So what we have for the first thing, vectors. What is vectors and why do we need it? Okay, so the answer for that is, so to define certain physical quantity, you all know what is physical quantity, right? So to define a physical quantity, we use most of the cases we use magnitude. For example, so I say what is the distance between me and a person standing next to me? Okay, it can be 1 meter, 2 meter. Remember during the COVID times we were asked to maintain a distance of 1 meter across any person standing in a queue or any place, right? So that is a distance, means only to define distance only magnitude is good enough. Okay, but there can be a physical quantity which will require more than one understanding statement to be defined. Those quantities are called as vectors. Means whenever you need magnitude as well as the direction sense to define a physical quantity, that quantity is called as vector quantity. Okay, so if you look at the definition that I've given over here, for scalar quantity, what we have, for example, mass, length, volume. So to define mass, how do you say? Do you say mass 10 kg north direction? You don't say that, right? Mass 10 kg, length can be said as 10 meters. You don't say 10 meters north. You don't say that. Length of any object, for example, length of kinetic, anything, length of a car. Okay, so length of a car is there. Okay, length of a desk is there. All of this can be, you cannot define with the help of direction sense. Only the magnitude is good enough. You don't say length of the car is 2 meters towards north or towards south. That's not how it's defined. Okay, so just the length will be defined using the quantity value itself, the magnitude itself. Okay, same way for volume, for density, for time, temperature, pressure, speed, work, etc. are all the scalar quantities. Okay, but if you take some example of vector quantities, what we have, quantities which are completely known when their magnitudes as well as their direction are known, but with their direction also known, then only we can say those quantities will be vectors. Okay, example you can check, instead of taking length or distance, what we call in this case, we take this as displacement. So we take this as displacement. Okay, chaliye. So what is this now? Force, velocity, acceleration, momentum, etc. are all vectors quantity. Okay, so again, we'll not stick to definitions today because I have taken some, but usually they don't ask questions directly on the definition. They ask you questions based upon the either a conceptual part of the definition, or they ask you questions from the formula point of view. So we'll focus on that itself. Okay, what is there now? This is a very important definition. This is a very important definition for our syllabus point of view. What is that? Directed line segment means for any line segment which has two defined points. What is the point, bacha? Initial and final point, and there's a line joining that. Means a portion of a straight line whose two endpoints are distinguished as initial and terminal point. Okay, it's called as, for example, I take like this. So I have defined over here this as initial point and this as my final point or terminal point. I'll call this point, this line, to be a directed line segment AB. A directed line segment AB. Directed line segment AB. From here only, bacha, what happens is we notify this as the vector AB. In the next slide, we'll see what is that. So we have to understand, first thing is representation of vector. How do you represent it? So for example, I draw a line like this. Okay, again, to represent we need both the points, very important. So we represent any vector with the help of directed line segment. I'll repeat myself, directed line segment. Okay, chaliye. So we need initial point, let's call this to be A, this to be B, A and B. Okay, and we draw a arrow, either A to B or B to A. It actually is not same. If I write here A to B, vector AB will be like this and vector BA will be like this. Okay, you can't say bacha they are same thing. Okay, they're two different vectors, they're not the same vector. Okay, so so the arrow is very important in the case of vectors, right? So this is the way to represent it on the figure. And how you write it, sir? Let's say I'm writing bacha AB. I'll write here vector AB from A to B. I write BA means I'll write here vector BA from B to A. Okay, that's how you're gonna represent it in the like symbol form. Okay, AB or BA. Now position vector of a point, for example, let's say I have a point in a, what do you call, in a space, 3D space. Let's say I have this as a point, okay, the point like this, A, with the coordinate of x1 comma y1 comma z1 comma z1. Okay, then how do you write bacha this vector? This will be a vector from O to A. What is O point? The origin point. Let's write the direction sense over here. So your initial point is at the origin, the initial point is at the origin, and the point A will be your terminal point. Okay, and so this vector OA, actually is called as the position vector of the point A. It's called as position vector of the point A. Of course, from where, bacha? From the sense, from the reference of origin only. Okay, so how you write this, bacha? You can written like this. You all know this now. I'll write it over here in the form of its rectangular components. Okay, so x will be your going to be your x component or I component. Okay, please check xi cap. Then I'll have plus y j cap plus z, it's x1, right? Sorry, x1 I cap, y1 z cap, and z1 k cap. So x1 is the x component or component of the vector OA in the direction of x. Okay, component of the vector OA in the direction of y is going to be y1. Same goes with z1 for the z component. Okay, this is how you represent your position vector of a point. Is that clear? Okay, how this is clear. Moving on now, direction cosines and direction ratio. Direction cosines and direction ratio. Don't worry, we'll learn this again in detail once more when we are going in 3D geometry. Okay, and why it's mentioned over here, bacha? Why? No, I'll tell you what. Because when you are dealing with questions in your examination, so they combine more than one topics together, right? So even in vectors, okay, what happens is you can find questions with the help of DC or DR coming in the examination. That's why I have taken a little bit over here also. Please allow me to do that. So what is there? The angle alpha beta gamma made by the vector R with the positive directions of x, y, and z, okay, is called as its direction angles. For example, sir, can you show? Of course I can show. Let's have a look. This is my x-axis, y-axis, and I can take this, bacha, as my z-axis, let's say. Okay, this, if I take my vector, let's say vector, what is that? Vector R. So what is my angle alpha beta gamma? Can you represent now? Yes, you can. This is your angle alpha. Okay, this is your angle beta and angle gamma. Alpha, beta, and gamma is the angle with the x-axis, with the y-axis, and with the z-axis subtended by the vector R. Please check. Okay, so these are called as your direction angles. The cosine values of these angles is nothing but cos I, cos alpha, cos beta, cos gamma. Right now, is called as direction cosines of the vector R. This is given the symbol L, if you remember. This is given the symbol M over here, and this is given the symbol N. Okay, there is one more property, bacha. What is that? L square plus M square plus N square equals to 1. Very important property, bacha. Very, very important property. The relation between the direction cosine of any given vector. Okay, this is clear. Chaliye, what is next now? Next we have is direction ratio, sir. This is nothing but, what is this, sir? Direction cosines. Alright, next, what is next, bacha? The next part is direction ratio, sir. Okay, what happens over here? In this case, you'll define it like this, sir. Please check. So this part y, this part x, and z will be your dr. Actually, it will be your dr. Okay, so how you write this as? Please check. So basically, you'll have, if you want to write this x, now you'll become multiply this thing with L. Okay, this thing with L. How come, sir? So please check. So why is this written like this, R, sir? Because if you remember, that's how you find the resultant vector, no? If a vector R is given in the form of xi cap, yj cap, and zk cap, right? Let's say vector R is given as xi cap plus yj cap plus, zk cap. How do you find the magnitude of R, bacha? Like this, no? X square, y square, and z square. X square, y square, and z square. All of you agree? Okay. So same thing, the same thing that you see over here, is written in the denominator of all these L, M, N value, right? So if you cross multiply, what are you going to get from the first one? Please check. From here, what you get is simply L times of the mod of vector R, okay, equals to X. In this case, they have taken as A, simply A. I can take this as A also, right? So simply they are taking this as A. So this becomes A equals to L times of R. Any confusion? I hope not. Okay, please understand. LR, if you multiply, no, this side, this is nothing but R, right? So you multiply this on this side, no, it will become bacha LR, right? L becomes X. So in this case, no, they have taken L, or we have taken X as simply A. A, B, C, we use the, you know, as a notation of direction ratio. So B will become bacha, B will become MR, and C will become NR. These are the notations which is used for our general direction ratios. That's why taken as ABC. Taken as ABC. Okay, please understand this. Very simple. All right. So this is the relation between your direction cosines and ratios. Okay. Now I have an announcement to make for all of you. I know you got to know all of already your surprise. Like what is there for you if you get a very good rank in your KCET examination. You have a cash worth, you know, cash prizes from our side coming your way, going up to 1 lakh rupees. Okay, for rankers. The list has been shared with you, right? I think in the live session we shared a list with you and asked you to take all the screenshot. If you have missed out, go ahead, check the session which was live just for the surprise that we were coming here with all of you. Okay, to share with all of you. Now I want to just tell you, if you're somebody who doesn't know, I want to tell you this right away once again. So we have come up with Abhyas KCET test series. Okay, so what we are doing over here, no? So we are starting from 17th of March. Okay, why this date, bacha? Because the exams will be mostly over by then. So then you can start your, you know, giving your energy on the what do you call, on your KCET examination, right? So right now you are busy with your boards, but once your exams are over, if exams are over, you can start giving your energy in the KCET way. Okay, now in this you get 35 tests. 35 tests. First 4 is free. You can get the free trial right now. Okay, in that you get physics, chemistry, maths, biology. Each paper will have 60 questions as per your standards, and you get of course question paper, you get your question papers solution in the PDF form. Not only that, you also get the video solutions from our side in the free trial also. Okay, now apart from all of that, what do you get, bacha? You get 31 paid tests. If you enroll in the paid program, you get 31 paid tests. In that you get full syllabus and chapter wise test. Okay, detailed video solutions and analysis, chapter wise one shot revision videos, chapter wise insights for last 5 years for KCET papers. Okay, so if you are somebody who is looking to have a very good, very bright career in the terms of KCET examination, okay, and you want to get a very good rank, this is something for you. After, you know, working so long with a lot of students, producing such a good results, Deeksha is here to help you again in your journey of KCET examination. So please make sure that you are somebody who is taking this test series, because which I'll tell you in one statement, this exam is based upon, you know, question papers, right? You have to solve the question to get the marks, right? That's how it is. It's a competitive examination. So the more you solve questions, more difficult question you solve, better chances of you getting a good rank is going to be there after learning of them. Okay, so of course this is a paper for that. If you solve so many papers, of course you will be through and will be confident going in your examination. Okay, so let's move on now. Let's get back to our session. Very important, one shot for vectors. What is there, sir? Now some definitions I've taken, will not take a lot of your time. Simple definitions are there. So we'll just quickly go through it and then move on. Works? Okay. So types of vectors, zero or null vector, please check whenever you find the vector's initial point and the final point as the same. I'll repeat myself. Whenever you find the vector's initial point and the terminal point or final point is the same, what happens is the vector is termed to be or called to be a null vector or a zero vector. Please check here. So basically A, D, D, anything. So start from this point and come back to this only, right? What is the answer, bacha? Zero or null vector. Okay, so the initial and the terminal point of a vector coincide, then it is called as zero vector. We write it as either zero vector form or simply write this as zero. That also is okay. That also is okay. Next, what is there, bacha? Unit vector. Whenever the vector has a magnitude of 1, that vector is called as unit vector. So please check. Magnitude is going to be only unit length, okay, along if any vector is called as unit vector. The unit vector in this form, how do you write this, bacha? Very important formula. Simple and very important, used in a lot of questions. Okay, used in a lot of questions. Okay, have a look. This is the way to find it. If I have taken an example, if I plus j plus k is a vector A, How to write it, sir? Same vector divided by the magnitude of the vector. Same vector divided by the magnitude of the vector. What is the magnitude going to be? Root of 1 square plus 1 square plus 1 square. Correct, now? Root of 1 square plus 1 square plus 1 square. How much is that? Root of 1 plus 1 plus 1. So root of 3. Root of 3. Please check. So I by root 3, j by root 3 and k by root 3 is going to be your a cap. Please check here. A cap. The unit vector across the vector A. Alright. So negative of a vector, what you do in this bacha? Of course, the magnitude will remain same. This vector direction will be reversed. Initially vector was like this, it becomes like this, of course. Okay, like this to this. Okay, please check. So we had 2i plus 5j minus k, it becomes minus 2i minus 5j plus k. Again remember this, the magnitude will not change, only the direction sense will reverse itself. Okay, let's move on now. Next we have is co-initial vectors, means whenever for any two given vectors we have same initial point, that is called as co-initial vectors. Simple. Okay, please check. So OA, OB, from the point O we have the vector A, so OA, and then we have bacha OB as well. So we call these two vectors to be co-initial vectors. Okay, same way we also have similar thing. I think we have here co-terminus vector. Whenever you have same terminal point, when we have same terminal point, we call this to be co-terminus vector. Okay, please check. Co-terminus vector. All right, let's get back to this. Now what we have next is collinear vector. Okay, whenever you have a vector either parallel to a part, okay, or parallel to itself also, means when I say two vector which is going to be parallel to each other or to another vector, okay, two or more vectors are said to be collinear if they have same or parallel support irrespective of their magnitude. It doesn't matter whether they're equal in magnitude or not. Okay, only thing that matters is whether they're parallel or not. I'm not saying that their magnitude will be equal. Let's say I take vector A and B, both are parallel to vector C. Okay, then I'll say A and B are collinear. Doesn't matter whether magnitude of A and B is same or not. Okay, so please check. So now how to write it? Like this: A equals to lambda B. A equals to lambda B. Okay. Chaliye. Equal vectors now. In this case, what will happen? You should have same magnitude and same direction. You should have, this is the condition, same magnitude and same direction. Okay. Only then you can say any given two vectors are equal. Doesn't matter what is their initial point. Nothing like that. Okay. If I can draw a vector like this and like this. Understand this? I have one more thing I want to say. We know this, right? I think you know this already. But the vectors, this is called as body length. Okay, this is the body of the vector. Represents what? Represents the magnitude. This body over here represents your magnitude. Okay, means if I draw a vector which is little longer than this, it simply means that this vector is bigger in the magnitude than the other two vectors. Okay, I hope this is clear. Actually, now next we have some free vectors. In this case, what happens is the terminal points are not fixed. Please check. If the effect of the vector depends only on the magnitude of the and the direction of the, and it is independent of the position of its origin or initial point. Okay, not fixed. Okay, it's called as free vector. It's called as free vector. Okay, let's move on. Now what we have, I already did this coterminous vectors. Okay, like vector means bacha same direction. Okay, unlike means opposite direction. Unlike means opposite direction. Like means same direction. Please check. Localized vector drawn parallel to a given vector through a specified point, as the initial point is known as localized vector. Okay, means there should be a specified initial point and should be drawn parallel to a given vector. Okay, the condition is for localized vectors. Last is a proper vector. Any non-zero vector is called as proper vector. Chaliye. Now we have to do question number 1. Let's solve it quickly. What is that? The vector in the direction of the vector I minus 2j plus 2k. Okay, and has a magnitude of 9. Let's call this to be vector A. Let's call this to be vector A. So basically they're saying that is equals to, there's a 9 of course over here, 9 times of, let's call this to be vector bacha, vector B. Okay, so they are basically going to be 9 times of B cap. 9 times of B cap. Won't you all agree? 9 times of the the magnitude is what, 9 times of the unit vector of this, correct? No. So basically direction is same, right? Direction is same. So how can you find that, sir? If I find bacha vector unit vector over here, what will it represent? The unit vector will represent bacha the vector across this same vector with a magnitude of 1. I'll repeat myself. Unit vector B will represent a vector across the same vector B with a magnitude of 1. So if I multiply that with 9, I get the vector across this vector only with a magnitude 9. I'll repeat myself. If the unit vector B cap or B cap represents, sir, unit vector across this direction of vector B, okay, then 9 B cap will represent a vector which will have magnitude of 9, okay, and in the direction of the vector B. That's what we're looking for, right? Okay, so we'll write here B cap as, please check, right? It'll become, okay, divided by okay, so root of 1 plus 4 plus 4 giving me I minus 2j plus 2k by root 9, no? So 3, this is the value of your B cap. Alright, so I get this vector A as simply, okay, 9 times of this B cap. How much is that? I plus 2j, sorry, minus 2j is there, no? Excuse me. I minus 2j I have, plus 2k is there, right? Okay. I minus 2j and plus 2k cap divided by 3 I had, right? So this I get cancelled and my answer will be 3 times of I cap minus 2j cap plus 2k cap. So going to be option number C is correct. Option C is correct. Please check. Done, right? Let's move on now. Okay. If alpha, beta and gamma are the angles made by a vector with the coordinate axis, okay, then find the value of this. We'll use the property or the formula of the trigonometry that we have. Please remember this. 1 minus cos square alpha for the first one plus 1 minus cos square beta for the second one plus 1 minus cos square gamma equals to how much, right? So let's just forget about the equal to right now. We'll solve it. There's no equation over here, right? So let's remove this equal to sign from here. Okay. Let's check the continuity now. So I get here equals to 1 plus 1 plus 1. How much is that? 3. 1 plus 1 plus 1 is 3. What I get if I take minus sign common over here, these terms, I get here minus common. It'll become cos square alpha. It'll become plus only cos square beta plus cos square gamma. Cos square gamma. Okay. How much is that? 3 minus, this is the property, right? 1, giving me the value as 2. So even though I told you a question can be asked in the case of vectors which might have application of 3D as well, okay, because vector and 3D, more or less can be combined together to make a question in KCET examination. That's why very important to make use of this. Shall we have a look? Okay, so answer is going to be 2, sir. Option D is correct. Option D is correct, bacha. I hope this is clear. Simple only, right? Very simple question. Let's move on now. Okay. So what we have next, question number 3, find a vector R equally inclined to the 3 axis. Okay, axis is okay, and whose magnitude is great. They've given here vector R's magnitude is nothing but 3 root 3, right? 3 root 3. Okay. So how do you write vector R cap in this case? It'll become, sir, if you remember, Li cap plus Mj cap plus Nk cap. What is Lmn, sir? Lmn are direction cosines. Are direction cosines. Please remember this. Okay, not ratios. Okay, not direction ratios. Direction cosines I'm asking, because we're talking about R cap, unit vector across the vector R, not any vector R. Okay, I'm looking for unit vector across the vector R. For that reason I can take this as Li cap, Mj cap, Nk cap. Please understand this. This is the standard result. Okay, so make a note of this. If you are there, make a note of this. Right here, unit vector across the vector R in terms of, I'll repeat myself, unit vector across vector R in terms of its direction cosines. DC will be given as Li cap plus mj cap plus nk cap. Okay, great. So I have this, given that equally inclined bacha, it means L equals to m equals to n, right? Basically what they're saying is alpha equals to beta equals to gamma, equally inclined, right? So alpha equals to beta equals to gamma, it means cos alpha equals to cos beta equals to cos gamma, right? It means L equals to m equals to n. I hope all of you agree, right? Chaliye. So right now use this property. We also know that L square plus m square plus n square is 1. From here I get 3 times of L square equals to 1. So L square equals to, please check, 1 by 3, which is giving me L equals to plus minus 1 by root 3. 1 by root 3. From here I can write this is also equals to m, also equals to n. Please check. Please check. Okay, this is clear. Now once that is known, I can write this vector form now. So vector r will be nothing but, please check, mod of vector r times of r cap, है ना, r cap. So right here 3 root 3 times of what I'm getting, plus minus of course 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. Okay, let's take this thing common, bacha. Let's take 1 by root 3 common, and plus minus also you take common, plus minus. Okay, so it will become, please check, I'll have plus minus outside, 3 root 3 is there into 1 by root 3 is there, and inside I get I cap plus j cap and plus k cap. It will become plus minus 3, excuse me, I cap plus j cap plus k cap. Answer is option number C. Option number C. Have a look. Is this clear? Simple only. Chali. Let's move on now. Question number, before question number 4, so I've done some questions now. Let's get back to again learning some concepts. What is there, sir? Addition of vector, bacha. So we have 2 rules to study: triangle law of addition and parallelogram law of addition. Okay, let's learn the first one. Triangle law of addition. What we do in this, sir? Of course, we'll draw a triangle. Okay, let's call this to be a point O. Point O. From here we write this vector. Let's say point A. Okay. Now from here we go, sir, again draw a vector till point B, till the point B. Okay, let's call the vector OA to be with vector A and vector AB to be vector B. Vector AB to be vector B. OA is vector A and AB is vector B. Okay, so only thing that is required over here, no, that this point, look carefully, should be the point where, okay, the terminal vector of the OA should be there. Terminal point of OA is A and initial point of AB is A again. Remember this, it should be, bacha, this only, right? Head to tail combination. Head to tail. Please check, head of the vector first one and tail of the vector second. Second vector is tail, first vector is head. That's the combination should be there. If that is there, I can draw a vector OB. I can draw a vector OB like this, okay, which will be called as vector R, given that R is equals to vector A plus vector B. This is the statement of, bacha, triangle's law of addition. I'll repeat myself. Only condition that is required is the point A should be having head to tail connection. The terminal point of the vector A and initial point of the vector B should be meeting at the point A. If that is there, then I can say simply resulting vector. What is R called as? Resultant vector. Okay, resultant, I was writing resulting, just one second. Resultant vector, please check, resultant vector, sir. Okay, given by A plus B. That's your triangle law of addition. Okay, can be used with the help of negative sign also. Okay, we know this, no? Even the difference or subtraction can also be written in the form of addition, right? So can be used there as well. What we have now, next is the parallelogram law of vector addition. Parallelogram law of vector addition. What do you do in this case, bacha? Of course, same way we'll go. So let's say I have a point O over here. From here, if I draw a vector till the point A, calling it to be vector A, okay, and this is vector B, let's say like this, okay, vector B like this. Of course, direction sense I hope you know by now. Okay, now only condition again over here also is that OA and OB, vector OA and vector OB is along the adjacent sides of a parallelogram. This is a condition. Okay, the sides OA, the vector OA and OB should be along the adjacent sides of a parallelogram. Then what happens, bacha? Simply sir, the diagonal of this vector, no, so this parallelogram, right, will become your resultant. Please check. This is a parallelogram, no? This is a parallelogram, right? OAB, let's call this to be, let's say, point P. So your vector will become, vector OP will be your vector R. So this diagonal actually will be nothing but vector R. We know this vector R is called as resultant vector. Resultant vector. How do you write this, bacha? Like this only. R equals to, again, vector A plus B. That's the same law. How does this can you verify this part? Of course, sir. This is a parallel vector, no? OB and AP is a parallel vector. So I can write this as B. This will become, bacha, B. Please check. Again, you can apply the triangle law. In triangle OAP, you can apply triangle law. It will become A plus B equals to vector R. But we are not using that. We are using over here directly as simply statement of parallelogram rule is nothing but if the two given vectors are across the adjacent side of any given parallelogram, then the diagonal will be your resultant. Diagonal will be your resultant. Please have a look. Okay, done. Vector drawn, question number 4 now. Vector drawn from the origin O to the point ABC, from the origin O to the point A, B and C, point ABC. Okay, with the vectors, this has given as vector A, this has been given as vector B, and this is given as vector 4A minus 3B, 4A minus 3B. Okay, I hope this is visible. Not, na? I'll rewrite this part, no problem. I'll rewrite this part. Okay, it's nothing but OC is nothing but 4A minus 3B, 4A minus 3B. All right, now what are they asking? Find AC and BC. Okay, let's find AC. For AC we'll apply like this only, no? Now please check direction sense. Is the terminal vector of the vector AC and the initial vector of the vector OA at the same point? I'll repeat myself. Initial point of the initial point of the vector AC and terminal point of the vector OA at the same point. Yes, sir. It means which I can write for here. In triangle OAC, by what, bacha? By triangle law of addition, of course. What I get? I get vector OA plus vector AC equals to vector OC. So what I'm looking for? AC actually. So from here I get vector AC equals to OC minus OA. What is OC, sir? OC is 4A minus 3B. Right here, 4A minus 3B. What is sir OA? OA is vector A. So minus vector A. What's the answer? 4A minus A is nothing but 3A minus 3B. Take 3 common here. A minus B. A minus B. Vector A minus B. Please check. Is that done now? This is your final answer. Okay, I write it over here just to make sure. AC is turning out to be 3 times of A minus B. This is one of the answer. Okay, let's proceed and find the value of BC as well. Let's find the value of BC as well. Okay, so for BC, bacha, we can apply this one, right? Oh, 1 second. For BC, we'll go from here to here, right? So we'll use triangle OBC now. So in triangle OBC, please check. I can write, bacha, please check. I can write directly now in this case. Vector BC is nothing but vector R, or basically OC. OC minus OB. Okay, how much is that? 4A minus 3B minus B. How much is that? 4A minus 4B. So giving me 4 times of A minus B. How much is that? Vector BC. Done. So AC is there, BC is over here. Please have a look. I hope this is clear. Okay, let's move on now. Chali. Now we have question number 5 as well. ABCD is a rhombus whose diagonals intersect at E. Okay, rhombus, sir. Okay, ABCD. Diagonals intersect, right? Diagonal first one and the second one at the point E, of course. Okay, they're saying find EA plus, okay, EA plus EB plus EC plus ED plus ED. EA plus EB plus EC plus ED. Now please check, if I take bacha EA as, let's say, positive, won't EC will become negative? So won't AC will be basically minus EA, because they are equal, no? We know this, right? Simply, sir, EA will be nothing but equal to minus of EC, right? Or EC is nothing but simply minus of EA, correct? Okay, so I can replace bacha this EA as minus EC. Same way, I can write EB like this, it will become negative. So I can write EB as simply minus ED. So I write here minus ED plus EC plus ED. Have a look. Cancel, cancel, cancel. Answer is 0. Answer is 0, sir. Option A is correct. Option A is correct. Okay, let's have a look. Done. Moving on now. Now we have scalar multiplication. We have two type of multiplication in vectors, right? Scalar, also called as dot product, and second is vector, which is also called as cross product, right? Scalar is also called as dot product and vector is called as cross product. Okay, so we use again we use the dot product for also the questions on perpendicular vectors, and we use cross product for the vector for the concepts of parallel or collinear vectors. Okay, please check. So what we have over here, direction of lambda. Okay, this is not a vector multiplication. Sorry. This is different, bacha. This is nothing but multiplying a scalar quantity. Excuse me, multiplying a scalar quantity with the vector. Okay, the quantity is given here as lambda. Okay, sorry. All right. So if you multiply that lambda with any vector A, if lambda is positive, what will happen? The direction sense will remain same. If lambda is positive, okay, what will happen? The direction of the vector. Let's say I am talking about the vector A, right? I'm writing the vector B as simply lambda A. Okay, then vector B's direction will remain same as A. I'll repeat myself. Vector B direction remains same as A if lambda is positive. If lambda is negative, means vector B and A will be in the opposite direction. Okay, this is nothing but scalar multiplication of, multiplying a scalar quantity to a vector. Okay, please check. So we have some properties over here. Associative law. We have associative law where we can multiply m to n. Okay, m to the n in vector A, or you can multiply n to the m vector A, or simply multiply mn together and then multiply to the vector A. Okay, we also have some distributive property. Okay, what is that? Like this, we can multiply m plus n to A will be nothing but ma and na. I can multiply m to A plus B also will remain same, ma plus mb, ma plus mb. Okay, so m is that, ma plus m with A will be ma, no, m with B will be mb. Okay, chaliye. Now condition for two vectors being parallel. Okay, two vectors A and B are parallel if and only if this condition is verified. Okay, where what is m, bacha? M is a scalar. Same thing I used over here, no? Please check this. Over here I use lambda, but in this case we are using m as the scalar. Okay, m is the scalar. Whether positive or negative doesn't matter. Means I can have a vector A like this, vector B can be like this also, and not a problem, like this as well. I can have vector C like this as well. I can write both of them to be parallel in nature. Even C is parallel to A and B is parallel to A. Whether it is positive or negative doesn't matter. Positive means same direction. This is positive, right? Here this is negative because of the opposite direction sense. Because of the opposite direction sense. Please check. Okay. Chaliye. So vectors A and B will have same or positive direction sense according to the value of M to be positive or negative. Moving on now, vector joining 2 points. Okay, so we would actually we use this without knowing it. I'll show you. I wrote no A as, remember, X, Y and Z. Okay, and let's say O as, I wrote this position vector, no? What is the position vector, bacha? What is the coordinate of O? Simply 0, 0, 0. So what actually do, no? When you are writing the vector OA, right? What you do actually is subtract X minus 0, I cap, okay, plus Y minus 0, J cap plus Z minus 0, K cap. Okay, so this will become, bacha, Xi cap plus Y J cap plus Z K cap plus Z K cap. Okay, so basically when we wrote the position vector of the point A with respect to the origin, same formula is being used. Okay, what is that? Please check here. The points are like this, no? So x2 minus x1 I cap, y2 minus y1 J cap, and z2 minus z1 K cap. Also, which I want to tell you, x2 minus x1, y2 minus y1 and z2 minus z1 is nothing but your direction ratio of the given vector, also called as direction ratio. This is also called as direction ratios of the given vector PQ. What is this first formula for? The magnitude of the vector PQ. We know this formula, right? This x component square plus y component square plus z component square. Simple things, nothing different. Okay, Chari, let's move on now. Now section formula. Okay, we have both for internal and external division. Basically, if you look at this figure here, the point P is outside the line AB. Here the point P is outside the line AB. Okay, this is a case of external division, sir. External division. What happens in the case of internal division, bacha? We have this figure, right? If you remember, we have A here, B here, and P will be between them. Okay, the point O of course, and this is the vector R of course, right? Is it clear? This will be a vector A and vector B. It will be M to N. This is a figure for internal division. The position is given, the vector is given by MB plus NA upon M plus N. Whereas in this case, please check, in the case over here, is given as vector R equals to MB minus NA upon M minus N. M minus N. Please check. Okay. All right. This is the case for where the point P is outside the vector. So division of the AB is done externally. AP is to PB is again M to N. Please check here. AP over here also. AP to PB is how much, sir? M to N actually. M to N only. Over here also same thing. AP to PB is same thing. But here this is external division. This is going to be internal division. Okay. From here only, what we do? We get this condition for midpoint formula. It's a special case, right? Where M to N is given by 1 to 1. We get here the concept for midpoint formula, right? Chaliye. So we have now we are dealing with scalar or dot product. We are dealing with scalar or dot product. As I said, we have two type of product, right? So let's have a look. How do you write it, sir? So if I have a vector like this A, okay, of course I'll have in terms of x1 I cap plus y1 j cap plus z1 k cap. Let's say vector B is also given here. Again same in this way, x2 I cap plus y2 we have j cap plus z2 k cap. Z2 k cap. What do you get, bacha? Is simply, please check here. A dot B is given by this is a symbol for your dot or the scalar product. Okay. Why the name was a scalar? Because after the result of the two, basically in the previous case we were multiplying a scalar quantity to the vector. Over here we are multiplying two vectors. So we are multiplying two vectors. But to multiply two vectors we have two different formulas, two different approaches. First approach is scalar multiplication. Okay, what it means is, in this case, bacha, the result will be a scalar. The result will be a scalar. Result will be a scalar. Whereas in the case of, one second, not visible I think. Whereas in the case of vector product, okay, in the case of vector product, what happens, bacha? It will be a vector quantity. If you are multiplying two vectors using the cross product or vector product, what you get the result as vector quantity. In the case of scalar product, you get what? It has scalar quantity. Okay, chali, let's have a look. So how do you write this? This is the simple writing it. A dot B is given by vector A, vector B, cos theta. Okay, all right. So what is theta, bacha? Theta is the angle between vectors, of course, A and B. Done. All right. Now, as you know, in the case of this, bacha, perpendicular vector, what will happen, sir? Please check. Theta will be, sir, 90 degree, no? Perpendicular vector means A will be perpendicular to B, right? A is perpendicular to vector B. It means theta is 90 degree. It means cos theta will be, bacha, 0 degrees. Will be 0, right? Okay. So I get here A dot B will become equal to 0. Because cos theta is 0, right? So this whole thing will become 0 RHS side. So I get A dot B as 0 for the case of perpendicular vector. So in the case of perpendicular vectors, we use the dot product concept, and in the case of parallel vector, we use the concept of your cross product. Okay. So if you want, you can actually multiply in the form of component also. What is x1 by 1 z1, sir? The component across x, y, and I cap, z, or z cap and k cap. Okay. So x and y and z component, I can multiply that way as well. So if you do that, what are you gonna get? If you write here in this way, you're gonna get this as, please check. It will become x1, x2, okay, plus y1, y2 plus z1, z2. Why, sir? Because, bacha, if you do I dot I, it will become 1, sir. How come, bacha? Please check. It will become, sir, I mod into cos 0, na? Right? Angle between I cap and I cap, both x and x axis. So 0 only, right? So I cap, what is the mod of I, bacha? It's a unit vector across I, no? So 1 only, right? It will become 1 into cos 0. So what is the value, bacha? 1. 1 into 1 into 1 is simply 1. That's why I wrote here I dot I is 1. Same way, j dot j is also 1. Also, k dot k is 1. And since you know this now, I can write this as well. I dot j, j dot k, or k dot I will always be 0. How come, sir? How come, sir? Please check. They are perpendicular to each other, no? I to j, j to k are perpendicular, bacha. That's why 0. I to j is perpendicular, right? J to k is also perpendicular, and k to I is also perpendicular. Okay. These are going to be 1. That's why I did not write here. Please check here. I did not multiply x1 with y2. No, sir. Because I cap into j cap will become 0, right? Please check. If I multiply x1 with y2, I'll have to multiply I cap with j cap. What I get, bacha? I cap with j will be equal to 0, sir. Okay. Hence, I did not multiply that. I multiply only with I and I. So I with I get x1, x2. J with j, I get y1, y2. K with k, I get z1, z2. I hope this is clear. I hope this is clear. Please check. Okay. Let's move on now. So same thing is written over here. Summary of this. If A dot B is 0, it means the angle is 90 degree. Okay. Positive means the angle has to be acute. How come, sir? First quadrant. Cos is positive. Okay. Less than means it has to be more than 90. Second quadrant. Obtuse, bacha. It has to be obtuse, sir. Second quadrant. Cos is negative, sir. Okay. Square of vector, bacha, what it means? Multiplying to itself, right? So square of vector means A to A dot, right? So A cos 0 simply going to be A square itself. That is it. Okay. Let's move on now. scalar product of two vectors in the terms of their rectangular component. I did that already. Please check here. I took as x1, x2, x3. Have a look. Okay, x1, y1 and z1 I took, right? And over here I took x2, y2 and z2. Okay, I got the same answer. Please check here. x1, y1 I got. x1, x2 plus y1, y2 and z1, z2 I remember. Getting right? It was nothing but a dot b. Please have a look. Right? Yeah. Give you the explanation as well. How we got this. Clear. Covered, sir. This part is covered, bacha. Please have a look. Done, sir. Right? 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 Let's move on. Angle between two vectors. Angle between two vectors. Since you know that there's already a cos part over here. So basically from this case, do one thing is get rid of this AB from here. Okay? So write this in this format. So A dot B divided by mod of A and B. You will get this in terms of cos theta. So theta will become bacha cos inverse of, please check, upon, done. Right? Okay. Again, if you want to write this angle with respect to your components of x, y, z in the direction of x, y, z, what you get? A1, B1. Correct? No? What is A dot B, sir? A1, B1, A2, it's going to be, sir, A2, B2 and A3, B3. A3, B3, right? Not visible. Please check, please check, please check now. Okay. So A1, B1, A2, B2 and A3, B3 divided by, what is this part, bacha? Nothing but your mod of A. What is this part, sir? Mod of B. Simple, na? Right? Chali. Same thing with the help of this. In this case, we have written with the help of rectangular components. That's all. Okay? Chali. So question number 6 now. If A and B are unit vectors enclosing the, okay, an angle theta, okay, such that mod of A plus B is less than 1. Okay? So we want to get into this angle, right? So we have to apply square. Then only we get dot product, right? Chali. So because we write like this, remember I just taught right now, square of a matrix is nothing but, sorry, forgive me, square of a vector nothing but vector multiplied to itself, right? So what we do over here, not cross product only, we do dot product over there. Okay, so A, B multiplied to itself, right? So it will be less than 1 only. Okay, so 1 square is going to be right there. So we write here as 1 only. Write this as, it becomes, sir, A square B square plus 2AB cos theta equal, not equal to, less than 1, right? Less than 1, sir. Okay, less than 1. I get this as 1 plus 1. How come, sir? They have given here unit vector, that's why. Plus 2 cos theta is less than 1. Okay, so how much is that? Please check here. 1 plus 1 is 2, right? So I can bring this over here. It becomes 2 cos theta is less than 1 minus 2. So 2 cos theta is less than minus 1. Basically, cos theta is less than minus 1 by 2. Less than minus 1 by 2. But it has to be greater than, remember this part, the range of cos theta, bacha. It has to be from where to where, bacha? From minus 1 to 1. Okay. In this case, we are saying that less than minus 1 by 2. Okay. But it has to be greater than 1, minus 1, sorry. This has to be greater than minus 1. That's a property, no? That we know at least. It has to be, what is the maximum value of this? It has to be from this boundary to 1. But in this case, we don't have 1 over here. So minus 1 by 2. What is the lowest value of cos theta, bacha? Minus 1. That's why I've written over here, minus 1. Now check this out. Okay. I'll apply cos inverse on both sides. You know what will happen if you do that? It will become cos inverse of minus 1. It will become theta. It will become cos inverse of minus 1 by 2. Cos inverse of minus 1 by 2. Now we know that cos is a decreasing function. What will happen, sir? It will start, what do you call? Interchanging the limits, the inequality. It reverse the inequality. So less than equal to will become greater than equal to. Less than will become simply greater than. I'll repeat myself. Less than equal to will become greater than equal to, and less than will become greater than. Now please check this condition from here. What I'm getting now? I'm getting this as cos inverse of minus 1. Simply pi. Cos pi is minus 1, right? So cos inverse of minus 1 will be cos pi, sorry, pi only, right? Forgive me. Theta is there. What about this bacha? Cos inverse of minus something. What do we write this as? Remember this. Pi minus cos inverse of the same thing. How is that going to be? Pi by 3. Right? Cos inverse of minus 1 by 2 will become bacha pi minus cos inverse of 1 by 2. So pi by 3. So pi minus pi by 3. Please check here. So pi here. We have theta over here. We have pi minus pi by 3 is how much? 2 pi by 3. So answer is going to be basically pi. So I can write this in this format. No, theta will belong to open interval 2 pi by 3 to pi closed. Right? Answer is going to be option number C. Please check here. Option C is right. Is that clear? Good question. Okay, good question. Chaliye, let's move on now. Let us move on now. So question number 7 now. A equal to 3, B equal to 4, then the value of lambda for which A plus lambda B is perpendicular to A minus lambda B. Basically they are saying that A plus lambda B into bacha A minus lambda B is nothing but bacha 0, right? Okay, what do you get? Dot is there, na? Dot is there, right? So A dot A, how much is that? Simply A square, correct, na? What about this bacha? A dot, with this I get minus lambda A dot B, correct? What about this now, sir? Lambda I multiply with this, I get here plus lambda B dot A. Okay, now the last term, lambda B times of lambda B will become minus lambda square B square, okay, equals to 0. We know this one property that A dot B equals to, sir, B dot A equals to B dot A. In dot product it is okay, but not in cross product. In case of dot product, this is allowed, sir, but not in case of cross product. Okay, chaliye. So we have this and this is cancelled now. In that case, I get here this will become, sir, 3 square. I don't have to write that actually. Okay, not have to write that. So it will become, sir, have a look, A square equals to lambda square B square by taking this term on this side. Okay, they've given perpendicular, right? Yeah, that's why 0. A square by B square equals to lambda square. So I get lambda equals to plus minus A by B. Plus minus A by B. What I get here? Please check. So my A value is 3. So plus minus 3 by 4. Right? Any option like this? Only V1 we have, option B is right. We don't have negative over here, right? Yeah, only one we have, option B is correct. Please have a look. What next now? Now we have, sir, projection of a vector on a line. Okay, so basically, of course, think about it. Projection of A on B means, sir, it means the part of A on B. The part of A on B. What are you going to do with that? So basically it means, sir, A vector multiplied with a dot with B cap. A dot with B cap. That's why we're writing here as, please check here, A dot with, what is B cap, bacha? B upon vector B modulus. Vector B upon vector B modulus. How much is that going to be? Please check here. Same thing, no? What I wrote over here. Same way if I'm writing here, B on A. So it'll become, sir, over here it'll become, bacha, divided by A. So basically B dot A cap. B dot A cap, right? Chaliye. If alpha, beta, gamma are the directions angle of a non-zero vector, okay, A is given as A1 I cap, A2 J cap and A3 K cap, okay, then to find, bacha, your cosine of alpha, basically your L value, for what you're going to do, right? A dot with I. Why with I, bacha? Because cos alpha represents your direction angle for x component, right? Basically for x axis, right? That's why dot with I. So vector A, this whole vector A dot with I divided by, basically what is this, bacha? What is this going to be? Check here, A dot I cap, na? Sorry, excuse me, sir. It'll become vector A dot with I cap, bacha. Okay, correct, no? Right? So it'll become, bacha, basically projection of the vector A across I x component. Okay, from there we get what, sir? Please check here. A1, what is the projection, bacha? A1 upon mod of A. Same thing, A2 upon mod of A. A3 upon mod of A. A3 upon mod of A. From there we can write cross multiplication. A1 becomes equals to A cos alpha. A2 is nothing but so A cos beta, and A3 is nothing but A cos gamma. What is A1, A2, A3? They are the projections of the vector A along x-axis, along y-axis, along z-axis in terms of, please check here, cos alpha, cos beta and cos gamma. Okay, done? All right. Chaliye, let me just erase this part, not required those many marks. Vectors or cross product. The last topic of this chapter is going to be your cross product. Very, very important. Very, very useful in 3D also. That's why very, very, very high weightage topic from this chapter. Okay, highly useful. Let's have a look. So vector product of two vectors A and B denoted as. So we were writing this with dot in the case of dot product. Over here we'll write this as cross. Other name is there, cross product. Okay, that's why the formula is A B sin theta n cap. Why n cap, bacha? Because result of vector product is a vector itself. Means I get the vector as a result of a vector product, bacha. Okay, that's why this is a, what is this, bacha? This is giving me a direction sense. This is for direction sense. That's why we have over here, please check, n cap. Usually we don't have, right? But in this case we have n cap. What is n cap, bacha? It is the vector perpendicular to both the vectors A and B. For example, let's say I take this vector A to be like this and vector B to be like this. Okay, A and B like this. What will happen, bacha? So vector A, and if you multiply A to B, A to B, A to B, what will happen to the vector? Your resulting vector will be in the direction opposite to this, basically coming out of this. So it will be a vector perpendicular to both vector A and B. Okay, so let's say C is a vector coming as A cross B, na? Basically I'm trying to say is C will be perpendicular to A and C will be perpendicular to B also. Both will be perpendicular. Because please check here, right now A and B is in 2D plane, but as you take cross product, what will happen? It will become a 3D plane now. So that the result will come in the 3D plane now, outwards, come outwards. Okay, if I take B to A, it will go inside, again 3D plane. Okay, so that's why n cap represents the unit vector perpendicular to both A and B, both A and B. Please check here, theta being the angle between the vector A and B, so sin theta. Okay, chaliye, let's move on now. Properties of vector product. Okay, the properties of vector product. So we have some properties that we have to remember. One of them is very, very important. For example, this is very, very important. This also is very, very important. Okay, these two are very important because used in questions a lot. Even this. Okay, please check. First one. Acha, this also is very important. A cross B is not equal to B cross A. Never. A cross B is never equal to B cross A. Okay, even though the magnitude is same, what will happen, bacha? A cross B means, let's say I'm doing A cross B, it was coming out, remember? Over here, please check, A cross B was coming out, but B cross A was coming inside. Can they be equal to each other? Never so. Okay, never equal. They might have equal magnitude but never equal in nature. That's why I'm saying here non-commutative. The vector product is never commutative in nature. Okay, next what we have, always remember A cross A is always 0, sir. How come, sir? A cross A will become A square sine 0, na? Sine 0. Why, sir, sine 0? Because A cross A was theta value, angle between A and A. I'll repeat myself, angle between A and A. How much is that? 0. In that case, what will happen to this? Sine 0. So whole thing is 0. Hence the result is 0, bacha. Right? So it's always 0. Okay, very, very important. This also. So A cross B plus C, the distributive property will be true over here. You write here AB plus AC. AB plus A cross B with A cross C with the summation. So distributive property over addition. Okay, What next now? You can multiply a constant scalar to any of them. X A B will remain same only. Multiply x to product or x to A or x to B will not change. X is a scalar, right? Will not change. Okay. What now? Same way, but I can multiply two scalars as well, x to A and y to B, or multiply x, y together and multiply that to cross of A and B. Doesn't matter. Okay. Now this one, sir. This property. Cross product of two vectors, basically square of cross product of two vectors, and if you add that to square of dot product, you'll get what? You'll get the vectors product in the square format. Okay, so you'll get this if you multiply. Basically, if you are taking square of the cross product plus, I'm saying this from here, please check. If you take A square, A cross B, the whole square, then you add this with A dot B, the whole square, it will become bacha A square times of B square. A square times of B square. Okay, that's the property. Now what is the next one? I cross I, J cross J, I cross I will be always 0. How come, sir? How come this is true, bacha? Remember, I cross I means again the angle is 0 only, na? I and I, what is the angle, bacha? Angle between x and x component is 0 only, right? Hence, sine 0 will become 0 over here, and over here. Same concept, okay? What about this, sir? I've taught you this, remember? Right here, I cap. Right here, j cap. And right here, k cap. Going from I to j, okay, you'll reach k. Going from k to I, you will reach, again, going from k to I, you'll reach j. Positively. But if you go ulta, outside, ulta if you go like this, or from here you go ulta again, from here you go ulta again, what are you gonna reach? Negative side. So minus, minus and minus. Okay, if you're doing I to k, you'll reach minus j. If you're doing j to I, you reach minus k, like that. Okay, please remember. So if you go, bacha, clockwise, you have positive, but if you go counterclockwise, you get negative, or anti-clockwise, you can write here. Please check. Done. Okay. What next we have, sir? Two non-zero vector A, B are collinear if only A cross B is equal to 0. Okay. Chali. Let's move on now. Vector product of two vectors in the terms of their rectangular components. Okay. Simple, sir. We have to take I, J, K over here. Okay. We have learned this in boards also. A1, A2, A3, please check. Okay, simply you're gonna take what? Determinant of this, and you get this result. I cap opening across the first row, I cap times of, please check, A2 B3 minus A3 B2, then it will be negative, no? So minus J times of A1 B3 and A3 B1, like that. Again plus K with that to come. This is your cross product formula in the case of your rectangular component. Okay, taking the cross product with the help of rectangular component. Okay, done. Now something in knowledge hub. What is there, sir? Area of parallelogram whose adjacent sides are represented by the vector A and vector B is given simply as the modulus of vector bacha A cross B. The modulus of A cross B. Yes, part of your NCERT. Okay, area parallelogram with diagonals A and B will be given by half of A cross B modulus. Okay, chali. Same thing. The area of the triangle will be given by same concept, half of modulus of A cross B. Okay, we have learned these formulas. We have done other questions on this as well. Okay, now what we have, please check here. If A cross B equals to 4, A dot B equals to 2, find the value of this property we had right now. A cross B, the whole square, plus A dot B, the whole square, okay, becomes equals to A square B square. What I get now, please check here. It will become 4 square now, and it becomes 2 square, right? This will be as it is. What I get now, 16 plus 4. How much is that? 20. Option is D. Option is D, sir. Option is D. Simple question. Done now? Alright. This is it for your session on vectors. Okay. Do let me know what you felt about the session. Anything else you need from my side, you can ask me that as well. Okay, right now I'm gonna end the session, and I hope to see you again very soon. Keep working hard. You have a very tough time ahead for your competitive examination as well. So I'll be here to support you in any way possible from my side. Just be positive, be focused, and any requirements you have, ask us. We'll deliver from our side. Okay, so I'll hope to see you again very soon. Till then, take care. Bye bye.